let's study temperature and temperature scales. Now, to really understand what temperature means, we need to start with two fundamental concepts. And those concepts are thermal contact and thermal equilibrium. So here's what we mean by those. Two objects are in thermal contact when they're able to exchange energy with one another. And they enter a state of thermal equilibrium when this energy exchange ceases. Now, thermal contact means that objects could be in direct physical contact, they could be touching, in which case they might exchange energy by collisions of molecules in one object with collisions of molecules in the other object. They don't necessarily have to be in direct physical contact to be in thermal contact. They could exchange energy via electromagnetic radiation, which you'll learn more about in Physics 7. So thermal contact is a broader idea than just being in physical contact. It means that you're able to exchange energy. And this energy exchange is called heat. So whenever there's an exchange of energy due to objects being at a different temperature, that's known as heat. And so with these two fundamental concepts and our definition of heat, now we can arrive at a definition of temperature, which goes like this. Temperature is defined as the property of a material that determines whether objects are at thermal equilibrium. So in everyday life, you're probably used to thinking of temperature as measuring how hot or cold something is. But hot and cold are kind of human concepts. They're not really absolute concepts that you can define in any real precise physics kind of way. So with this definition of temperature, it actually becomes more precise. We say that temperature tells you whether objects are going to exchange energy with one another. If an object is at a higher temperature than another object, it will give some of its energy to the objects at lower temperature. It will exchange heat if those two objects are in thermal contact, and that heat exchange process will continue until the objects reach thermal equilibrium. At that point, they're at the same temperature. Now we use a few different scales to measure temperature. There's three common ones. The most commonly used one in the world is the Celsius scale. And Celsius is defined where 0 degrees is the freezing or melting point of water. And 100 degrees is the boiling or vaporization point or condensation point of water. Now, 0 degrees is not the coldest possible temperature. Things can be negative degrees Celsius, and 100 degrees is certainly not the hottest possible temperature. You can have temperatures in nature that are thousands of degrees Celsius or even more. But these are two common everyday situations. We often encounter water freezing, we often encounter water boiling, and that's why it's kind of convenient and natural to choose that as a temperature scale, so that there are 100 degrees, 100 steps in between these two temperatures. Now the next scale we'll talk about is Kelvin. And Kelvin uses the same size degree as Celsius. So you take a Celsius degree, it's the same as a Kelvin degree, but we just start in a different place. We start the Kelvin scale at the coldest possible temperature that exists in nature, which is known as absolute zero. And you might have heard about absolute zero before, and maybe you've heard it said that absolute zero is the temperature at which all molecular motion stops. That's not really accurate because quantum mechanics says that you can never have zero molecular motion. That's not allowed by the laws of quantum mechanics. So absolute zero is just the coldest possible temperature that exists in nature, where atoms and molecules have their minimum possible kinetic energy. It's not totally zero. And to go between Celsius and Kelvin, you add 273 degrees to your Kelvin degrees to get Celsius, 273.15. And then we have one more scale, Fahrenheit scale, which is still common in the US. No one else really uses it, but in the United States we still do. And Fahrenheit is, again, kind of defined around these reference points having to do with water. 32 degrees is water freezing. And 212 is where water boils or vaporizes. So there's 180 degrees in between those two reference points. And I always forget why it's defined that way in the first place. There's some complicated historical reason why they defined 32 and 212 to be those 2 points, and why they picked 180 degrees to be between them. As far as we're concerned, we just need to know that the scale is still commonly used in the US, and so we'll need to convert between Fahrenheit and Celsius, or Fahrenheit and Kelvin, or Celsius and Kelvin, and you can look at those conversions in your book. I'll give you a couple problems to practice those. It's pretty easy.